hydrogen iodide is introduced into 3 identical 500 milliliter bulbs at 350 degrees centigrade. Each bulb is opened at different time intervals and analyzed for iodine by titrating with 0.015 m hypo solution. Calculate Kc for the reaction hydrogen iodide forming hydrogen and iodine. तो इस रिएक्शन में HI is changing into hydrogen and iodine, and this iodine formed is titrated with hypo solution. Molarity of hypo solution is given, titration readings are given. From this we can calculate the amount of iodine formed. Now from the balanced equation we can see 1 mole of iodine reacts with 2 moles of hypo solution. So moles of iodine divided by moles of hypo solution will be 1 by 2. Now from this moles of iodine will be equal to half into moles of hypo solution. Now moles of hypo solution will be molarity of hypo solution into volume of hypo solution. Molarity of hypo solution is given as 0.015, and for the volume of hypo solution we will consider the third reading, which is equal to 28.68 milliliter. So converting this milliliters into liters, moles of iodine is 0.215 into 10 to the power minus 3 moles. Now we know the moles of iodine. Initial mass of hydrogen iodide is 0.28 gram, since we are considering the third reading. So moles of hydrogen iodide will be equal to 0.28 divided by 128. 128 is the molecular weight of hydrogen iodide. Now if the degree of decomposition of hydrogen iodide is alpha, then 2 moles of hydrogen iodide decomposes to form 1 mole of hydrogen and 1 mole of iodine. Therefore 2 alpha moles of hydrogen iodide will decompose to form alpha moles of hydrogen and alpha moles of iodine. So remaining hydrogen iodide is initial amount of hydrogen iodide, that is initial moles of hydrogen iodide minus moles of hydrogen iodide that decomposed. Now we know the moles of iodine, so value of alpha is equal to 0.215 into 10 to the power minus 3. Putting the value of alpha, we will get the remaining moles of hydrogen iodide and moles of hydrogen. So Kc is equal to, now volume of the bulbs is 500 milliliter. So converting it into liters, it is 0.5 liters. So in moles per liter, the concentration of hydrogen will be moles of hydrogen divided by volume in liters. Then iodine will be moles of iodine divided by volume in liters. And then moles of hydrogen iodide. Moles of hydrogen iodide will be 1.757 into 10 to the power minus 3. So moles of hydrogen iodide divided by volume in liters raised to the power 2. Solving, the value of Kc will be equal to 1.49 into 10 to the power minus 2.